Welcome to Module 3, Lesson 14, where we will be solving some more inequalities. And today's lesson will actually focus on a carnival. Okay, so all of the problems that we will complete today will be about a local carnival in some fictional town, your town, that will last 5.5 days. Okay, so with no further ado, let's get right into it and with our opening exercise. Okay, yeah, so just a couple of things to remember. We're talking about inequalities as we just did in Lesson 13. Very similar, of course, when you're writing an inequality, very similar to writing an equation. It's just that now we no longer use the equal sign as we would in an equation, but we use either a greater than sign, a less than sign, a greater than or equal to sign, or a less than or equal to sign. Okay, so we're not using the equal sign when we're talking about inequalities. Okay, but again, everything else is exactly the same when we are writing inequalities and then solving them. Okay, of course, there are solutions, as we had mentioned in last lesson as well. There are several, at times, infinite solutions for inequalities, whereas an equation will bear you but one solitary answer. Okay, so let's go ahead and start this with this classwork opening exercise. The annual county carnival is being held this summer and will last 5.5 days. Use this information and the other given information to answer each problem. Okay, so we're going to take this step at a time, and I want you to, if you could, just come on back and check after each step. First, so you can see where you're going to write an inequality, then you're going to solve that inequality, and then you're going to interpret the solution. Okay, so we'll do those one at a time. Okay, so here we go. You are the owner of the biggest and newest roller coaster called the Gentle Giant. The roller coaster costs $6 to ride. The operator of the ride must pay $200 per day for the ride rental and $65 per day for a safety inspection. If you want to make a profit of at least $1,000 a day, and notice this term "at least." Okay, it's not a very specific. If you want to make a profit of $1,000 each day, no, it's saying at least. So that is a key or a clue to the fact that this is an inequality. We'll be using one of those signs. Okay. I'll start again there. If you want to make a profit of at least $1,000 each day, what is the minimum number of people that must ride the roller coaster? Okay, and again, we're talking about per day. Okay. All right, so your first part here is to write an inequality that can be used to find the minimum number of people, P. Okay, we're going to have that P, so you know that's going to be our variable. P, that must ride the roller coaster each day to make the daily profit. Okay, and again, well, not again, but just to remind you of what profit is. Profit is you take all of your, you take what you make, which is called your revenue. That's money in. Okay, subtract away all of your expenses. Those are the costs. Okay, and that equals your profit. Okay, just to remember. A little reminder of what that word, very important word, profit, actually refers to. Okay? So go ahead, and just like we did in Lesson 13, if you need to go back and take a look at how we did that, go ahead and write the inequality that you can use to find the minimum number of people that must ride the roller coaster each day to make the daily profit of $1,000 each day. Okay? Go ahead and do that and come on back. Don't solve yet. Okay, here we are back with my having written the inequality. Okay, now the 6p I got from knowing that the a roller coaster costs $6 to ride, and the P, of course, is going to stand for that people, because we are solving for the minimum number of people, and that's the P. Okay, that's our variable. Okay, now I am subtracting away, or adding a negative 200 to that, because each day I need to pay $200 for the rental, and then I'm paying $65 for the safety inspection. Okay, so those are coming out. Those are my expenses here. We talked about those expenses. The P part over here, the 6P, that would be my revenue, money that comes in. Okay, and over here, of course, is the profit. So you can see this here as being this right here. This actual equation here, revenue minus expenses equals profit, is reflected in this statement right here. But of course, I am using a greater than or equal to symbol because we want to know at least $1,000 each day. Make a profit of at least $1,000 a day each day. So $1,000 would be included. That's why we include that equal to sign. And of course, $1,000 is on this side. Okay? All right, and then I just simplify that by combining my like terms, and I end up with this as my final inequality, okay, which we can now solve. So if you have that inequality ready to go and ready to solve, go ahead and do it. If not, make your adjustments and make it look like this one here, and go ahead and solve that inequality. And come on back. Okay, and here we are back with the solution, and starting off with my inequality here. And again, going through the same moves as I would with any other equation. In this case, of course, I am adding back 265 to both sides here, adding 265 because I am trying to eliminate this negative 265 here, okay, to get rid of that. Remember, it's always the additive inverse that is being applied here, okay? If this is a positive number, then I'm subtracting, but if it's a negative number, which it is here, I am adding, okay? Then I end up with 6P is greater than or equal to 1,265 people, okay? And I'm talking about people here. So these aren't dollars and cents now. These are people, okay? And if I go ahead and make my ones, okay, again, these if-then moves, as they are called in this curriculum at times, we're making, adding the 265, we're making zeros by multiplying by the multiplicative inverse of the variable's coefficient. We are making ones, okay, coming up to 1p. So if I do multiply 6p by 1/6, of course I get p, and then if I multiply 1/6 by 1265 times 1265, or 1265 divided by 6, I come up with 210 and 5/6 people. Okay, so that is a very interesting number, okay, because we know we can't have 5/6 of a person. All right. So if I could ask you, what do you think? Think about that. What do you think that might actually mean? How many people would need to visit or need to ride this gentle giant roller coaster in order that the operator of this ride can make that $1,000 profit? Okay, $1,000 profit. So if we could think about that, we could actually plug it in if we wanted to. If we did it, go ahead and plug in 210 and 5/6 into our formula, okay, our original equation, okay, which would be either this one or this one, and we would do the math. Okay, and I'll just do it for you. I think you probably know the answer to this already. But no, it turns out that that's like $900 and some odd dollars, okay? Close, okay, because 5/6 is very close to 1. But the truth is, the answer to this problem, because the question is actually the minimum number of people. What are the minimum number of people that must ride the roller coaster each day. And the answer would actually be not 210 and 5/6, because truly we never talk about 5/6 of a person, but 211. You'd have to go up to 211. So if we plugged 211 into to this one right here, we can go 6 times 211, which is 1,266. Okay, subtract away 265. We would get $1,001 is greater than or equal to 1,000. You can see how close that is. Okay, $1,001, and that is correct. This does check and this does work, but you can see that if anything less than that would not quite make it, number of people wise, because 210 would not work. We could even check 210 if you'd like, but we know. Okay, we can plug into 10, and if we plugged into 10, change this here, 1,260 minus that is actually 999, and that is not, I'm sorry, I shouldn't put that over there. This is, of course, 1,000 on this side, but that's 900 and 995, yeah, and that is not greater than or equal to 1,000, so that does not work. Okay, so yeah, so we figured that we have an answer of 211 with the answer to our question. The answer to solving the inequality, of course, would be this here, okay? But again, like we had said, 210 and 5/6 people, there's no such thing as a 5/6 of a person. So therefore our answer would be 211, okay? Okay, so let's move on to a few examples here. This example 1, a youth summer camp has budgeted $2,000 for campers to attend the carnival. Okay, and when an organization of some sort budgets something, that means that's the amount of money that they have. You cannot go over. Okay, so there's no more than $2,000. You budget for something. That's how much they put into the account, and it can't go over. Well, sometimes there isn't. People go over budget. For example, to make a movie, many of these film producers go over budget. But in this case, we're going to say that since this camp has budgeted for this $2,000, they cannot go over. Okay? So let's move on. The cost for each camper is $17.95. Okay, so that's per camper. So you can imagine start to imagine what our variable will be, which includes general admission to the carnival and 2 meals. Okay, the youth summer camp must also pay $250 for the chaperones to attend the carnival, and then $350 for transportation to and from the carnival. Okay, what is the greatest number of campers who can attend the carnival if the camp must stay within its budgeted amount? What is the greatest number of campers who can attend the carnival if the camp must stay within its budgeted amount? Okay, and that's, again, the greatest number of campers. Okay, that's what we're solving for. Okay? All right, so go ahead and you know how to do this. Why don't you go ahead and start with your inequality, write out your inequality, and then come on back, and if you'd like to check that, and then we'll solve. Okay. Okay, so here is our inequality written out. 1795C, of course, is the cost per camper. Okay, right there. I added 250 and 350 because those were the costs of the chaperones and the transportation. Okay, so $17.95 per camper plus 250 plus 350 had to be now less than or equal to 2,000 because that is our budget. Okay, that is our budget. So again, if I just go ahead and simplify that by combining these two like terms, I come up with this final here inequality to begin. Okay, so go ahead and use that. Hopefully you have that as well. And go ahead and use that to solve the inequality. Okay, so here we are back to solve our equation, or actually our inequality. Okay, very, very careful to state that correctly. And again, same steps. Take away 600 from each side, making zeros. 17.95C is less than or equal to 1,400. Okay, again, this is $1,400 dollars here, but that gets translated into actual campers. Okay, as we move along down here, and again, multiplying by the reciprocal of the C's coefficient will yield us that C is less than or equal to 77.99. Okay, and again, when you're doing this step right here, hopefully this has become quite apparent, but when you're doing this, and it looks so complicated, it looks a real messy, 1 over 17.95, which is not something we normally do. I mean, you don't really write fractions that way, but times 1,400, in essence, what we are doing is we are just taking 1,400 and, of course, dividing it by 17.95, okay? So that, in effect, is what we are truly doing. We'd like to show it fractionally, simply because most of what you'll be doing in the future will be fractions. There'll be fractions involved, okay? So, again, now this is similar to the other problem where we had 5/6 of a person. Here we have 0.99 of a person, okay? And this is kind of sticky. I mean, it's really, it's close. What do you think about 78 campers going? 78 campers going. You think that'll work? Yes or no? 78 campers. Because our inequality solves out to be the campers have to be less than or equal to 77.99. So if we are very, very strict to their budget here of $2,000 only, it looks like this 78 is not going to work. But let's just go ahead and plug it in just for fun. If you have your calculator handy, you can do this along with me. Okay, so let's go ahead and do the math here. Let's go ahead and plug in 78, okay, for our C right up here. So if we do 17.95 times 78, if you guys would do that on your calculator, I'll do the same here. Times 78 equals, so that comes out to be $1,400.10. Okay. Now, if I add, of course, I'm going to add that $600 in expenses to that, and you can see. And if I add 600, okay, which I know I can do without doing this, but that's $2,000.10. Ooh, that is more than the budgeted $2,000. Okay, so if they were so incredibly strict, ridiculously strict with their budget, we could not take 78 people. We would only be able to take 77, okay, because that would yield us a figure that was less than or equal to $2,000 in cost, okay? But I think in this case, if this were the case, I think this youth camp would go ahead and pay the extra 10 cents, I might imagine, okay? And that's the real world. Alrighty? Okay, so let's go ahead and move on to, and again, if there are any questions on any of this, if this is confusing at all, hopefully you're having lots of fun with it, because it is a lot of fun, I think, and especially once you get better at it. So let's go ahead and move on to example 2. Okay, so here we have an example 2. The carnival owner pays the owner of an exotic animal exhibit $650 for the entire time the exhibit is displayed. Okay, so again, some key language in here. $650 for the entire time the exhibit is displayed. So you can that right away. That's going to tell you that's a one-time charge. Okay, just so you're paying attention to that, and you don't turn that into any type of variable. Okay, so yeah, so the carnival owner pays the owner of an exotic animal exhibit $650 for the entire time the exhibit is displayed. The owner of the exhibit has no other expenses except for a daily insurance cost. Okay, so nothing else is being charged. Okay, so you have a daily insurance cost. So if the owner of the animal exhibit wants to make more than $500 in profits, $500, so more than $500, you can imagine that what symbol we're going to be using now for inequality. For the 5.5 days, very important, what is the greatest daily insurance rate he can afford to pay? Okay, so a little bit different twist on all of this. Okay, now it's not the number of people, which the last two examples were talked about, but this is the greatest amount of money he could pay daily for insurance. Okay, okay, so this one may be a little bit trickier, but go ahead and take all these little pieces, this piece, this piece, this piece, and put it together and create an inequality. Okay, and come on back. Okay, now this one might have confused you a little bit. I mean, the way it's worded may have been a little bit confusing to you. I'm not sure, maybe not. Okay, so here's the deal: is that the carnival owner now is paying this owner of this exotic animal exhibit $650. Okay, so for the entire time the exhibit is displayed. Okay, it's going to be there for 5.5 days. And that's how much money this guy is going to get paid, okay, to have it there. It doesn't seem like such a great deal to me. It doesn't look like he's requiring any entry fee either. So the only revenue, okay, remember this idea of revenue, he's going to receive is the $650 here, okay, $650 in revenue. All right. Now his expenses, it says he has no other expenses. Remember here, no other expenses outside of this daily insurance cost. Okay, so if you're going to be open 5.5 days, that'd be 5.5, and then I, of course, is the amount. excuse me, is the amount of insurance, the insurance payment that we're trying to solve for. That has to be greater than 500. Okay, has to be greater than $500. Okay, because we want him to, because they're asking here, he wants to make more than $500 profit. Okay, more than. All right, so that's this more than, and this is a profit statement over here because this is the revenue. This would be his expense, and then this would be the profit, and he wants to make more than $500. Okay, so this, and again, if you don't have this as your inequality, I understand, because it is a little bit confusing. I had to look at it a couple of times myself. Okay, so always thinking, we mentioned this idea of profit. Anytime there is profit in the, let me uncover profit since I messed it up there. Whenever you see profit, remember you're going to have revenue minus expenses, and it's going to be equal to your profit. And okay, so we're going to have revenue, and you're going to subtract away expenses, and that's what we've done here. This is the revenue, and these are our expenses. Okay, all right. So let's go ahead and solve this one. And again, if you don't have this one here, just go ahead and write that down now and solve it, and come on back. Okay, so here's our inequality solved, and you may have had a little difficulty with this, and you may have not gotten the answer that you see here, but I'm going to explain a little bit why. Something had to be done here, a key thing, and that was we had to reverse the the inequality. Okay, we had to actually change the direction of the sign. Okay, and there are two different reasons we would actually two different situations in which we do that. And you may remember earlier in this unit or in this topic, we talked about something called preserving or reversing an inequality. Okay, but let's just go through this, and I'll point that out when I get to it. Okay, so here we go. We have our inequality, and that's 650 minus 5.5i is greater than 500. Okay, and you can see right away how kind of screwy things look, because always going to complicate things when you see the the number, single number, and then the variable following it, okay, with a negative sign in between. Always a sign that something is going to have to change. Okay. So first thing I did is, again, I subtracted away, just trying to isolate that variable still. So subtracted away 650 from both sides, and you can see what a mess this makes. Well, kind of a mess, sort of a mess, but we have negative 5.5i is greater than negative 150. Okay, so now in order to make one, okay, to make one single I, I need to multiply by the reciprocal. In this case, that reciprocal is going to be a negative number. Okay, so I need to multiply a negative by this negative, which will give me the positive I, which is nice. Okay, and then I go ahead and the negative times the negative on this side, and I get a positive number as well. But you'll notice what I had to do here is I had to change the direction of my my inequality sign. Okay, and let's just take a look over here. So there are two different occasions where you would change the direction of an inequality. Okay, and one of those, and this is the one that we just, the example that we just had here, is when you multiply or divide by a negative number. Okay, when you multiply or divide by a negative number, and that's to get your 1 to, when we are trying to get that variable down to 1 unit. Okay, or when you swap sides. Okay, so you could have, something like 2y is greater than 9. Okay, so if I swapped sides and put the 9 on this side, actually, no, we wouldn't actually do that. Let me just show you when we would do that, because we may end up having something like this. 9 is less than 2y. Okay, now if I want to get that variable on the other side, on the left side, where we'd like to have it be, that would have to be 2y is greater than 9. Okay, so you can see I've changed the direction because I've actually swapped sides here. Okay, I've swapped sides, and that's this. This is not what we did just now. Okay, this did not pertain to what we did now, but I'm sure we will see that in the near future. But when you multiply or divide by a negative number, okay, you need to change the direction of that inequality. Okay, which we had to do here. Now, it's complicated to explain why. But what we can do, because you may have ended up with the answer y is greater than 27.27, okay, you may have come up with this, all right. The way we can prove that it's not correct, and again, this may or may not help you remember to do this in the future, but we can actually plug this in. We can plug this I is greater than 27.27 by, let's just say, let's use 28, okay, which is greater than 27.27. So if we plug that 28 in to our inequality, okay, up here, let's go ahead and do that. Do it down here. So that would be 650 minus 5.5 times 28 needs to be greater than 500. Okay, if you have a calculator handy, you can maybe help me with this. I'm going to do that right here on my calculator, and let me go ahead and do that. 5.5 times 28 and that equals 154. Okay, this equals 154. So 650 minus 154 is actually 496. So 496 is not greater than 500. So that does not work. So this will not work, okay? Because that can't be the answer. Because if it were the correct answer, then 28 should work. But as you can see, using 28, plugging 28 into the original inequality gives us an incorrect answer. Okay, so let's go ahead and let's just continue this, and let's go ahead and if we do reverse that symbol and we use this as our answer. Okay, let's go ahead and, so this says I is less than 27.27. So let's go ahead and use 27, just the number 27, which would be correct if this were correct. Okay, so then if we plug in 27, let me just get a new sheet of paper here. So 650 minus 5.5 times 27 needs to be greater than 500, okay? And let's go ahead and do that. So that's 5.5 times 27, plugging that in, that's 148.5, okay? So 650 minus 148.5 equals 501.5, which is greater than 500. And you can see that that does indeed work. So a number less than 27, right here, actually worked. Okay, we'll talk more about that, reversing of the inequality in the future, I'm sure. But just know that that whole idea, just think of multiplying something by a negative number. Think of it as an anti-gravity machine or something, which doesn't quite make sense on Earth, okay, to multiply by this negative number. So you have to change it around. So you do just the opposite. You know, that whole idea of the negative sign leading to doing the opposite of, maybe you can just keep that in mind when it comes to working with inequalities. Okay, so here we go. So here, let's do our last example before we finish this lesson. All right, here we go. So we have several vendors at the carnival sell products and advertise their businesses. Shane works for a recreational company that sells ATVs, dirt bikes, snowmobiles, and motorcycles. His boss paid him $500 for working all of the days at the carnival, plus 5% commission on all sales made at the carnival. Okay, so let's just stop for a second and analyze that sentence. Okay, so he paid him a flat fee of $500. Okay, for working all days. Okay, so he worked this five and a half days, right, at the carnival, and he got $500. Okay, so that's a flat amount. All right, but now this idea of commission, I'm not sure if anybody remembers this idea of what commission is. We talked about this, oh boy, it's been a long time. But what happens is anything that he sells, whatever amount it is, he gets 5% of that total. Okay, so for example, if he sold $500 worth of stuff, okay, if you $500 worth of stuff, he would make 5% of this would be profit. Would be his, what we call commission. His boss would pay him that. So to multiply by 5%, you'd multiply by 0.05, and you can see that that would be $25. Okay, so he would get $25 commission, which would be extra pay for him. And there are many people who work on this commission idea. People that sell cars, people that sell pretty much anything will make a commission, okay? Usually get paid very little in salary, but they get paid the bulk of their income comes in what we call commission, okay? So that's what commission means. So that's what that whole idea of 5% is over there. And that 5%, as you can imagine, is going to be needed in this inequality that we write, okay? So here we go. Let me just start over from his boss. So his boss paid him $500 for working all the days at the carnival, plus $500 commission on all sales at the carnival. So what was the minimum amount of sales Shane needed to make if he earned more than $1,500? Okay, so if he earned more than $1,500, what is the minimum amount of sales? And that's going to be a dollar amount that Shane needed to make. Okay, so go ahead and see what you can do with these numbers and these little figures that I've circled and underlined, and put together what you think may be a correct inequality. Okay, so go ahead and try that, give it a whirl, and come on back. Okay, so here's our inequality. Okay, and as you can see, the way I've written it a little bit differently than we're used to. So what we can do right away is change it around, because we can do that. We could be at liberty to do that because we have plus sign. Things are positive, thank goodness. So let's just go ahead and so I put 5 over 100s. Now, do you know what that 5 over 100s means? Yes, it means, I'm just assuming you got it right, the answer to that question. But yeah, that means 5%. So 5 over 100 is the fractional representation for 5%, or 0.05. Okay, and you could have put 0.05s. Okay, this works. Okay, as well. But I just used the 5 over 100 because you know how we are very fraction happy when we solve our inequalities and equations. Okay, so here's where we stand. So the 5 over 100s is the 5% commission. Okay, because the S actually here stands for sales. Okay, so those are the sales. This is the amount of sales he needs to make, because for all of his sales, you're going to multiply by 5 over 100, or 0.05, or 5%, to get the amount of what we call his commission. Okay, plus the other $500 that he gets paid just for working there. Okay, that's up here, just for working there. All of that needs to be greater than $1,500. Okay, $1,500, because right here it says more than $1,500. Okay, so our inequality is, and it's not greater than or equal to. Okay, because it doesn't say needed to make if he earned at least $1,500. Now, at least, we could have used greater than or equal to, but it's more than, so therefore we use the more than inequality symbol, okay? All right, so there it is. Here's the inequality, and if you don't have it written like this, go ahead and write it like this, and then go ahead and solve, all right, and come on back. Okay, so here we go. We have our inequality written. 5 over 100, or 5% S, plus 500 is greater than 1,500. Again, applying our if-then moves, making 0 here, subtracting 500 from both sides. We end up with 5 over 100 S is greater than 1,000. And again, multiplying by the reciprocal. See, the reciprocal looks a little bit different this time. It's actually top-heavy. Okay, because it is the reciprocal of 5 over 100, and that's why we'd like to practice with these fractions as much as we can, okay? So 100 over 5 times 5 over 100s, of course, is going to yield us the single s, greater than, if we go ahead and multiply the 100 over 5, okay, which is the reciprocal of that 5 over 100, times 1,000, okay, right here. We can go ahead and do a little cross cancellation here to make it a little bit easier, okay? So then 100 times 200 is actually 20,000. Okay, so he needs to have sales. Shane needs to have sales of $20,000, or greater than $20,000, in order for him to earn more than $1,500. Okay, more than $1,500. So, of course, what I'd like to do, because we'd like to go back and actually plug in. Okay, so to plug in our solution here, which is this $20,000. Let's go ahead and plug that in to that equation there. And let me go ahead and get a fresh sheet here. So 5 over 100s plus 500 greater than 1,500. And then, again, if you'd like to solve this along with me, you can, or yeah. Okay, so go ahead. We're going to plug in now. We came up with our answer here was 20,000. So if we plug in, so we have 5 over 100 times 20,000. Okay, and plus 500 greater than 1,500. Okay, and yeah, so here we are. We have 5 over something. I just got a message there in the middle of that recording, so I'm just going to go back over. I'm not sure what you missed here, but yeah. So now I am plugging in the 20,000 for the S. Okay, we're trying to see if this works out. Okay, so yeah, 5 over 100 times 20,000. Okay, we can do it. We can do it this way. That's 200. And so that's a what is that? 1,000? Yep, 1,000 plus 1,500 plus 500 is greater than 1,500. Okay, and let's see, 5%. That's 1,500. It's greater than 1,500. Okay, and that's actually not true, huh? So we need to maybe go back and look at this again. Let's go ahead and look at this one more time. Okay, let's go ahead and start over. I'm sorry, I got a little confused there. Just to go back, but it's this. This of course does not work. Of course, why doesn't it work? Let's just go back and look, because our solution says it needs to be greater than $20,000. So of course, $20,000 being plugged in does not work. Okay, so we did prove ourselves correct by being incorrect, I guess. But so if we went ahead and did it times $20,000 and $20,001, we would have come up with something that was a little teeny weeny bit more than $1,500. Okay? Alrighty, so let's go ahead and close up here with our lesson summary. Again, if there's any, it's going to take a lot of practice with this for many of us, but you need any kind of extra help at all, please do reach out, call me or email me. Okay, so a lesson summary here is written in your binders as well. The key to solving inequalities is to use if-then moves to get zeros, blah, 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 blah. Yes, we've been talking about that over and over again. The key to solving any inequality is the same key to solving any equation. Okay, so going over all this, I guess, is just kind of a reiteration of what we've been talking about. Adding and subtracting opposites will make zeros. Okay, according to the if-then moves, a number that is added or subtracted, it does not change the solution to the inequality. So it's the same exact thing. Multiplying and dividing numbers makes ones. Okay, that's multiplying by the reciprocal or just dividing by the straight number. A positive number that is multiplied or divided on each side does not change the solution of the inequality. Okay, but here is the major point, and if you want to go ahead and highlight this or underline this one very, very darkly, it's this right here. However, very, very important, okay? Multiplying or dividing each side of an inequality by a negative number does reverse the inequality sign. Okay, very, very important. Important to note. Okay, is that point. Okay, I am trying to get a new color of highlighter here. There we go. That would be good. Let's do that one. Okay. Yeah, so however, multiplying or dividing each side of an inequality by a negative number does reverse the inequality sign. Again, somewhat complicated to explain, but just take it as fact, okay? All right, so given inequalities containing decimals, equivalent inequalities can be created which have only integer coefficients and constant terms by repeatedly multiplying every term by 10 until all coefficients are constant. I'm actually not sure why this has been thrown in here. Maybe we could just disregard that for now. How about we just do that with that, because that's kind of confusing me. Let's not even worry about any of this anymore. Okay, this is pretty much stuff that is given stuff, and we'll be talking about that again and again. Why they throw these things willy-nilly out there, kind of confusing to me. But anyway, as far as lesson summary, I would say this is probably the number one thing that we learned in the course of this lesson. Okay, is that idea of when we reverse an inequality sign. Okay. All right. So good luck with your exit ticket and your problem sets. And again, like I said, and I've said over and over again, please call me if you'd like to come in and have a little extra help. Okay.